Hi Year 7, welcome back. Today we are going to do ellipse construction, and I've said when it's a circle, not a circle, and that's when it's sideways on or when it's slightly at an angle. If you think about it, a circle, when you turn it slightly to one side, doesn't look like a circle anymore. And ellipses are very important for designers because if you think about it, everything has a curved edge to it that we design. An ellipse is basically part of a curve. It's a full circle or it could be part of a curve. So being able to do curves at angles is actually a very important skill. I'm going to teach you two methods today. Those of you who are feeling really like they could do it, go for the second method. It's very complicated. It's called using a trammel. It requires you to get a very important piece of equipment together, which is called a strip of paper. So find a strip of paper. You'll see it all from the beginning. You need a pencil, a rule and a strip of paper. Dead easy. The first method you shouldn't have any problem with. But I'm introducing you to a few other concepts there that we use for technical drawing and a few words. It's important you begin to take the words in because the words are all part of your key vocabulary for technical drawing. I shan't say any more than that, and I should get the rest of the video done and say next week we're moving on to something else yet again that I hope hopefully you'll enjoy immensely, and I'll see you again soon, and I hope you're looking after each other and take care. Okay, bye. Hello guys. Today we're going to really test your mathematical skills and your skills in what we call geometry. In our area we call it technical drawing, and you will need a piece of equipment, actually most definitely a pencil, and you will also need, if you can find one somewhere, something to measure with, a rule. If it's a centimetre rule like this, that's fine too. If you're lucky to have millimetre rules, so it doesn't say 1, 2, 3, 4, it says 10, 20, 30, 40, even better. But they're exactly the same, just one's a centimetre, one's a millimetre rule. We generally work in millimetres, but centimetre rule will do. And the other piece of technical equipment you're going to need today is a strip of paper. Oh, that's really hard. Okay, and that's it. There's no colours needed, nothing else. It's just those pieces of equipment. Now, in technical drawing, we tend to have other pieces of equipment as well, which I want you to get used to, because in the next few weeks you're going to be taught how to use them and the drawing methods that we use them with. I have here two set squares. One has two equal angles and a 90-degree angle, and one has an acute angle and a less acute angle, or obtuse angle. Actually, it's not an obtuse angle, less acute angle, and a 90-degree angle at the bottom. As we know, in a triangle, all angles add up to 180 degrees. So that's easy to identify. Take 90 away from 180, leaves 90. Divide it in half because they're equal, and that would mean that's what we call a 45-degree set square. It's a 45-degree set square, whereas this one has an acute angle, less acute angle. These angles will definitely add up to 90 because that's already 90. And now looking at that, I know it's a 30-60. So 30-60 degree set square. We use these set squares for particular drawing methods, which you are going to be taught. One that looks a bit like 1-point perspective, and it's called oblique. And one that looks a bit like 2-point perspective, but it's called isometric. Now I say looks like because the difference between using these methods and doing them in perspective is perspective, as you know, you'll have a vanishing point and lines will go to that. So your lines will seem to come back together. But when we're using technical drawing, we always keep our lines parallel in any direction. So parallel being keeping the lines the same distance apart. So if you're going backwards 45 degrees, all lines will be going back at 45 degrees. This is a very specific method, and it seems a little bit false, but a little bit like that. But we are going to see an example of it today, which is why I wanted to introduce you to it. Another piece of equipment, which is quite important to us, if we're doing formal technical drawing, is this. Not a compass. A compass gives you direction, magnetic north or west or whatever. This is a pair of compasses, sharp point graphite. And we use that to draw, as you know, circles, which is fantastic if you've got a compass. But if you're sketching and you use circles like that, it looks a bit strange to have a hand-drawn sketch and all of a sudden a formal circle. So it's a good idea as a designer to try and learn to draw circles freehand. Now, if I don't think about it and do it very quickly, I can generally do a pretty reasonable circle. It's slightly off, it's not perfect, but it's slightly off. Another way to do it, and I can guarantee because of the fact I haven't practiced this for a long time and because I draw circles quite quickly now, I won't get it perfect. But if you draw a square and you then mark halfway point on each of the lines that make up the square and then draw an arc between each of those lines, like that, and like that, and then like that, and you've got a circle. And then if you were to use that wonderful crating method I was teaching you the other week, so imagine you've got a 1 point perspective cube, so lines are beginning to go backwards together, and I want to make a three-dimensional sketch of a cylinder, for instance. If I now take just where that circle's turning a line going backwards, an imaginary line, and the same here, just where the circle's turning a line going backwards, and then mirror that arc at the back here. Sometimes that's not easy to do, not when there's a camera in the way. Okay, then if I use some of that wonderful shading you've been taught, so we can imagine that's shaded here, and then maybe a bit of cross hatching or hatching going across the face. It's easy to see how you can quite quickly draw in a three-dimensional shape by hand without using a compass. And today we're going to start to look at that. But the most important thing is when you draw a circle at the side, it doesn't look like that. And no, it's not an oval. When you start to turn a circle on the side, it changes its shape. And I'm going to take something here immediately to show you what I mean. So this is a circle until I do that. And now it's not a circle. And it's even less of a circle then. So it's important you realise that circles, as you change the actual angle you're looking at them, change shape. But that's not an oval. An oval will be perfectly the same size each end, and that is not. So you're going to learn how to draw these. These things are called ellipses. And there's two methods of drawing them. We take the square method that you've already just seen, and we also have this method of using this piece of paper which we call a tramel. So, the sheets today say very simple: ellipse, a circle, curve at an angle. And in the box I've said, when is a circle not a circle? When you look at it from the side, then it is an ellipse. This is not an oval. Being able to draw an ellipse is an important skill in design. Part of an ellipse is a curve. So most things have got some sort of ellipse in them. Most designed objects have curves in them. So if you're designing something that's got a curve in it, inevitably you have to learn how to draw curves. You're going to learn two ways of constructing accurate ellipses. One way is crating, again, which is at the box form, and the other way is with a tramel. That wonderful piece of paper I've told you to get yourself armed with, that's a tramel. I'm going to write on it, tramel, so you can see. That is what a tramel is. That is it. That is it with a couple of marks on it that you're going to make with a rule. Okay, you can see how we've got various things drawn here, and again the cylinder in the box showing you how you're using crating to its maximum. Here showing you how when you turn a circle at an angle, obviously it becomes more and more shallow. It doesn't look like a circle anymore, but it's still a circle, just at its side. So the first page is to practice what we've just started to have a look at. We're going to bring several things together here. There you are, there's the square divided up, and there's the arcs drawn. There's the square as if it was drawn in what we call isometric, which is that 45-degree angles going back. Again, divided in half at the faces, and what you have to do is you have to draw the circle in that, so it's like that. And you've practiced it, that's figure 2. Figure 3 shows you these styles I was talking about. So this first style here, which you can see at the bottom here, is in fact oblique. And I'm going to show you on this page here, B is oblique. This one here, which doesn't use perspective again, and it's just drawn so the lines are parallel. If you look, the lines are actually parallel. All the lines are going parallel. They don't go back together. They don't go back to a vanishing point. And it's slightly at an angle both ways, is isometric. If you remember, this uses the 30-60 set square. This uses the 45-degree set square. This one here you should recognise. This one's that one up there. This, oh yeah, by the way, this one, isometric, is over here. Before I forget that. Not having a good day spelling today. My dyslexia's kicking in really badly. Okay, so that's isometric. This one here, as you should recognise, it's up there. This is 1 point perspective. I'll just put 1 pp there. You know 1 point perspective. And that leaves this one, well, there can only be one left. And that's 2 pp, 2 point perspective. I've made a little blue arrow on each of these exercises. And I'm saying that face, that face, that face, and that face. I want you to have a go at drawing a circle as an ellipse, i.e., go work out the halfway point on each of these lines as you're looking at them, and try and draw an arc from each one. Whoops. Like that. So you've got one there, and this one here, again, halfway point on there. So I'm going to have a very sharp angle there, shallower one there, very sharp one there, and a very shallow one there. So if I do that, so look, you want guidance, have a look at this one down below. This one here, so that's your 2 point. Actually, I've gone the wrong face there. I should have done that face, shouldn't I? Look for the deliberate mistake today. Try that face, that might be easier. You can always try drawing them on all the faces. That's good fun too. There you go. And then this one here, it's this face. I've just put another line there, and that sharp angle there, and a shallow angle there. One there. And then on this one, I said this face, and again, divide that in half, that in half, that in half, that in half, and visually try and work it out with your eye. Sharp angle there, going down to there, and a shallow one there. So we should have, some are better drawn than others, depending on how, I'll make them slightly darker, so you can see them. We'll do that one there. That looks a bit better. And this one here. There you go. So that's the exercise for drawing using crating. As you remember, this method is called crating when we're drawing things in boxes. Right, I've set this part of the demonstration up in advance because otherwise this video is going to go on far too long. So I've actually shortened the whole thing, a bit Blue Petery really, but here we go. Drawing with a trammel. Remember, trammel is spelt, I've written it out here, look, is spelt T-R-A-M-M-E-L. It's a strip of paper. It's just a strip of paper with a straight edge. Okay, the trick to doing a trammel is just being as accurate as you can. The first thing you've got to decide is how long, how wide you want your ellipse to be, and draw then 2 lines that cross that are longer or bigger than the ellipse. In this case, I want my ellipse to be 70 millimeters on its sort of fattest point, and on its broadest point, that's the widthways, I want it to be 160 millimeters. If you've got a centimetre rule, that's 16, and that would be 7. Obviously, if they're crossing halfway, that would be crossing at the 3.5 centimetres or 35 millimetres, and that will be crossing at the 80 millimetre part, just say. Okay? The lines themselves are going to be longer. So you know you've marked there, that's 160 from that point there, and from there to there, that's 70. But the actual axes are longer. Then what you need to do is a centimetre in from the end of your trammel, mark a little line and mark P next to it. Then you want to take your trammel where the P is, from the middle of where the lines cross and to the top of your minor axis, or the bottom of your minor axis, doesn't matter, where you want your ellipse to be the top of. So in this case, it's going to be 70 millimeters broad, its height, broadest point, fattest point, but actually it's 35 millimeters because that's halfway, and I've marked A. Then the P to the end of the major axis, where you want it to be really wide in terms of how big it's going to be. We said it's going to be 160, so that's 80 millimeters from that middle part. And I've marked a point for B. Now the trick to a trammel is P is the point. Just think P point is where you're going to keep marking your dots. And the other trick is you must always keep A and B on the major and minor axis. It mustn't be off it, up here or up there. It must always be on the major or the minor axis. Even if it goes longer and longer and longer, so you're trying to go all the way down to beyond the end of the shape of the ellipse, doesn't matter. Just keep them on the axis. So if you're going that way round, or if you wanted to mark, say for instance, this side, you would again, keeping it on the axis. If I do that, so you can see it's upside down, I would have it going round like that, but keeping A and B all the time on the axis. Okay, and the same would apply over here, over there. If I straighten it there like that, and if I keep A and B on the axis. So you see how we're doing that. A and B always stay on the axis. Okay? All right. So I'm going to now mark the top part of this arc. I'm not going to do the whole of the ellipse, otherwise I'll be there for 50 years. Okay, so I'm going to now mark the top part of the arc, which has gone below the width, if you like, of the ellipse. I'm showing you how you use the longer, you make your axis a bit longer, even if it means that it looks a bit strange. You'll work it out in a minute anyway when you see it finished. Okay, so I'm going to mark another point there. What I'm doing is I'm sliding it down the axis, so B stays on the minor and A stays on the major. Pay some music this. And then round to almost the top there. I'm going to fill in one more there, I think, just to give you an idea. So A is on the one axis, B is on the other axis. And at the P point, I'm marking a dot. And then, if you just do a freehand mark, I have drawn a quarter of an ellipse. And if I was going to do the next part of it, which is over here, I'm going to be here forever if I start carrying on with this. But I think I'll show you a bit more. So if I go on this side, for instance, A and B are all lined up there, look. I'm just going to go back a bit, I think. Otherwise, I miss dots. So A's on the one axis, B's on the other.
I'm doing a dot at P. Obviously, the more accurate you are, I'm trying to do this really quickly, the more accurate you are, the better it's going to be. So keeping A on the one axis, B on the other, and again, A on the one axis, B on the other, A on the one axis. Now I'm going above that point there, look, doesn't matter, still keeping it on the axis, A on the one, B on the other, and do check each time you go to make those points that the A and the B are on the axes, because I notice I've moved a bit there. So I'm going to go back and do that one again. I was obviously trying to be a bit too quick there. So I'll put one there, and I'm going to put one there. And of course, the more dots you do, it's a bit like join the dots afterwards, isn't it? The more accurate it can be. That one's all over the place. Just ignore that one. Okay, so then if I draw my line there, as you can see, I've got two parts of it. And I do the same then by changing the position of the trammel on the axis. As long as you have one, the A is on one axis and the B is on the other axis, the P will give you the point at which you mark your final mark to draw your ellipse. And that's all I'm going to do, folks, because otherwise this video is too long. So I'd like to have a go at trying to actually draw your ellipses in various methods. Remembering what these different methods are. Remember we talked about isometric and oblique and 1 point perspective, 2 point perspective. I have not written these things on here because it's a lot to learn in a very short time. I'm just introducing you to them so you've got an idea. I'd like to have a go at doing that, and I'd like to have a go at making your own little trammel. The instructions are down there, look guys, and drawing your ellipse. Okay, have fun, got a week, and I'll speak to you soon.